there has always existed a mathematical and computational interest for life. And in this video, my classmates Juan Fernando Angulo Salvador, Cristian Gallo Peláez, and who speaks to you, Sebastián García Costa, we're going to talk to you about the Conway's Game of Life and shortest path out with him. So, first of all, what is the Conway's Game of Life? Basically, it was invented by John Horton Conway back in the 1970s, and it is a cellular automata that lives in an infinite grid where each cell is either dead or alive, and the state of each cell depends on the following rules. The first one is that any live cell with 2 or 3 live neighbors survives to the next generation. The second one is that any dead cell with 2 or 3 live neighbors survives as well in the next generation. And the third one is that any of the others live cells will die, and all of the others dead cells will still dead in the next generation. And these simple rules lead to incredibly complex results, just as simulating life. But also, what is more interesting about is that it is Turing complete, which means that we could build a computer just with these rules. So next up, let's see how we implement this.
Diving into the implementation, the grid was made using a canvas where we painted the grid lines and each one of the grid blocks using a white color for the live cells and a dark gray for the dead cells. You can zoom in and out and pan across all the grids. And one important aspect of our implementation is that our grid is made of a toroid. This means that the first row is connected with the last row, and the first column is connected to the last one. Now let's take a look for a simulation run of our game.
Hello everyone, my name is Juan Fernando Angulo Salvador and I'll show you Conway's Game of Life demo. First I'll talk about the interface. Down here we have a menu which you can hide by using this button. It has the minimize, maximize, and hide tab buttons. It also has a button to close the application. And here you have a timer, a play and resume button, a reset button, a step button, speed slider, and in here you have the shortest path functionality, which you can choose the algorithm to use. It also gives you the number of generations of the live cells. So in here I have some cells already drawn, and I'll show you how they work. Looks crazy, right? Now I'll show you the shortest path functionality. First we'll choose BFS algorithm, and you can see I'll draw 2 points and it will start searching for the endpoint. So you can see BFS is like a brute force algorithm which expands in all directions to find the end cell. So in here you can see how it is working until it finally reaches the end cell. Okay, so thank you very much.